Hello, this is Philip Schotten, and I'm with 엑센츄어 Public Sector AI Lab in Brussels, where we test and evaluate the most advanced AI tools for public sector applications. Today, I'm going to show you a generative AI command center that uses Palantir software, Planet Lab satellite data, and European Space Agency hydrological data to simulate the impact of climate change on French nuclear capacity, and then uses generative AI to create a co-pilot to help manage the impact of water levels on cooling capacity that can be taken. We use the software to perform tasks including the collection of satellite imagery and downloading the imagery for each of the nuclear facilities. We can use the Earth observation platform Meta constellation to pick an area of interest, a particular mission time, and then identify which satellites will be overshooting the area at a given time. Then we task that satellite to pull the imagery directly into our library, where we use computer vision to measure the decrease in water levels. Based on this information, we can compute a vulnerability index for the site. We've done that for each facility in France, and we color-coded those facilities based on their vulnerability to hydrological drought. For each of the facilities, we can now drill down to better understand their real vulnerability. In this case, the Cruas facility is the facility with the most near-term risk. We can compare the water levels from 2019 to the area of the river in 2021. Computer vision models indicate an 11% decrease on water volume available to cool the reactors. At this point, we've used Palantir's generative AI functionality to create a secure co-pilot for an operator to use in the control center. This allows us to see work orders or maintenance activities, enables us to monitor outside temperatures, and to receive alerts if any issues are detected. In this case, we have seen an alert come in, which is saying that persistent high temperatures are causing a 10% reduction in cooling efficiency for this system. From here, the operator can open the co-pilot to take action on this alert. Let's do that now. Once in the co-pilot, the operator can put in the alert that I received and ask the co-pilot what actions I might be able to take. The co-pilot will come back with potential actions such as reducing the nuclear power output, connecting the supplementary water sources, or sending out notifications of reduced power output. In this case, I would like to connect supplementary water sources, but I need a little bit more information to be able to do that. I can ask my co-pilot to open my available water sources. The co-pilot will then go and open up my available water resources, and I can see the alternative water resources in my data system that I might be able to connect to. Furthermore, I can see a comparison of each of those water sources based on different factors such as distance, where I can see that in this case, Le Donoso is the closest facility or water source to my facility. I could also look at estimated cost of reconnecting to a different alternative water source. In this case, we can see Le Donoso is the most cost-effective water source as well. Based on this, I can now make the change to connect my alternative water source. I can now open my cooling managers, which allows me to select the water source I want, and then I can change the cooling status to open and give it a new value. So in this case, we'll open it to 0.9 for the cooling level. I can update that change and have it sent to my downstream systems. Let's say that I wanted to send an email to the facility manager detailing the change that I just did. I can use my co-pilot to do that. I can ask my co-pilot to send an email to the facility manager, and it will come back with an action that I can take called Email Facility Manager. This will bring up a template where I can put in who I want to send an email to, the subject, and then I can put in the body of the text. In this case, I can also ask my co-pilot to draft the email for me, and it might even be in a different language than I speak. In this case, the email is summarizing the issue that we ran into, the actions that we took, and then letting them know who to reach out to if there's any further information needed. And I can then finally ask the co-pilot to send out the email. From here, the operator might return to the facility command center and continue monitoring activities for new alerts or new issues. Overall, this demo has shown the case of monitoring nuclear facilities in France for vulnerability to hydrological drought, leveraging cutting-edge geospatial tools as well as generative AI components. The same concepts could apply to many other use cases such as supply chain, workforce management, enterprise functions, and citizen services as well. This concludes the demo. Thanks a lot for your attention.